All right, guys. So what we're going to do is we're going to continue to work on the P and S wave chart here, page 11 of your reference table. Okay. The thing is that the last question that we did was this. Yes. Did we write out our given list for this? Yeah. Yes. Okay. So what is given? What's important about this? Blair, give me one thing.
The arrival time.
The arrival time, right? So what arrival time? So we have arrival is what?
11:40 a.m.
Okay, 11:40 a.m. Good. What else is important? The fact that it's the P wave, right? So that tells us which curve we're going to be using. What else is important?
The distance.
Hold on, Brandon, you have it?
The distance traveled.
The distance traveled, and you're going to say the same thing? Okay, so the distance is how much, Brandon?
8,000 kilometers.
8,000 kilometers. Oh, I can put another zero in there somewhere. Okay. Is there anything else that's important about this? What it's asking for, which is?
Origin time.
All right, we're looking for the origin time. Good. Question mark. We don't know what that is. Okay, so what we do know is that this wave is going to travel 8,000 kilometers, which is going to be here. Right? We know that it's the P wave, right? So we have to first find out before we do anything else, right? That's what we're given. Oh, this has been crazy all day. This is what's given to you just from the problem, right? So step one is going to be figure out the travel time, right? Because we need to know how long did it take for the P wave to leave the epicenter and make it to you guys at the seismic station. So when we do this, we go up. Hopefully yours is a straight line, right? And we go over, right? And how long did it take?
11 minutes, 20 seconds.
Right, so that's going to be 11 minutes, 20 seconds. Okay so far? Right? Did I do anything crazy yet?
Nope.
And I say yes.
This looks pretty normal.
All right. So step two, okay. We can now use that travel time to figure out what the origin time is. Well, you guys told me that the arrival time is 11:40, right? So that's 11 hours, 40 minutes, and technically 0 seconds. Right? Even though we don't say it that way, it is 11 hours, 40 minutes, and 0 seconds. Right? The origin time is the time that it started. So it's going to be the time behind the arrival time. Okay? So we know it took 11 minutes and 20 seconds for the P wave to meet its destination. You guys at your seismic station, yes? So in order to do this, we have to subtract 11 minutes and 20 seconds from 11 hours, 40 minutes, and 0 seconds. Okay? Watch very carefully what I do. Okay? 11 hours, 40 minutes, and 0 seconds is the same thing as saying 11 hours. Oh, okay, I hate this board. I officially hate this board. Okay, 11 hours. You done now? 39 minutes and 60 seconds. Right? It's the same thing. 11 hours, 40 minutes, 0 seconds is the same thing as saying 11 hours, 39 minutes, and 60 seconds. Right? All we did is you borrowed. I know you guys didn't learn how to subtract that way. I know you guys learned some funky 5s and 10s way the new math, right? Some very weird thing. But when everybody else learned it, you borrow from the number next to you, right? So we're borrowing from the 40 to make that 60. So now your origin time, right, is going to be 11 hours, right? What's 39 minus 11? 28 minutes and 40 seconds, and it's still in the morning. Okay? Questions on how we did that? All right? But do you see why it's important for you to write out a given list? Right? What you're given, what you're looking for, and the steps in between to get there.
Like basic geometry.
It is. Okay, so we're going to do another question. No, it's still the same question. Okay, copy that down while I erase the board.
Can I take a picture of it?
Why?
My iPad's on the stand.
So why don't you use the charger?
Oh, what? Do you have a charger?
I don't
Yes, I
understand
do.
how you're a tech geek but don't have a charger.
I have a charger.
I don't have a.
Okay, no big deal.
I have a. Yeah.
But no,
No.
I don't have one either. So.
Thank you, Mr. Dallas. I appreciate you very much.
No problem. All right, write this down, and no problem. And I want you to write out your given list.
That's the only one.
Only that guy.
I would have it. Oh, yes.
All I want you to do is write it down, and then write out your given list. Let's start with the easy part. So especially for those of you guys who are having trouble with the test, this is what you should be doing, right? You should be breaking down pretty much every question, okay, unless it says, what does this mean, right? You should be pretty much breaking down every question with given lists and saying what's important, right? So I know some of you guys keep saying you're having trouble, right? This is what I want you to do, right? Underline what's important in the question, right? Right off to the side, this is what's given, this is what's asked of me, specifically what is asked of me. All right, so let's see. What are we given? The what?
The time?
The time, right? So what kind of time? Arrival time, origin time, what is it? Arrival time, good. So we have our arrival time, right, is 12 p.m. Okay, what else are you given?
The distance is 600 kilometers, 6,000 kilometers.
Good. The distance is 6,000 kilometers. What else are you given?
Where it says 12 p.m. I put in parentheses P-wave.
Ooh, that's good too, right? The fact that this is specifically for the P wave. Okay. What else are you given in this question? What's important? Second.
What time the S wave is going to arrive?
Right. It wants you to find the arrival time. Bless you. Specifically for the S wave. So that means this is going to be more complicated than what we've done so far. Okay? So, looking at it. Right? Did everybody at least have a given list down?
Yep.
Guys at home?
Yo,
Okay, so you got all this information already? That's a lot of information just from the question, right? So we know that it's going to be a distance of 6,000 kilometers, right? So here's our 6,000, and we go up to the P wave, and we know that the P wave takes 9 minutes and 20 seconds to arrive, right? From when the earthquake happened until when the earthquake arrived to you guys at the seismic station, right? It took 9 minutes and 10 seconds. Well, it's not asking you for the travel time for the P wave. It's asking for the arrival time of the S wave, right? Which means that we have to look. They're still both going 6,000 kilometers. You did not change the distance between the epicenter and the seismic station. It's still 6,000. But now we're asking about the S wave. The S wave takes a total of 17 minutes to get to the seismic station. Now, this is where everybody gets it wrong.
Aren't we supposed to find the origin time?
Yeah, you don't have to.
You don't have to.
Man,
So the steeper the line, the slower it is?
the steeper the line, the slower it is. Yes. Okay, so this is where everybody gets it wrong. Because I told you it takes 17 minutes for the S wave to arrive. Right? So I guarantee you if this is a multiple choice answer or question, one of the choices will be 12:17 p.m. and you will all fall for that because that is not the correct answer. Now, Owen, you could go back and figure out the origin time and then add 17 to it. You could, but that just takes a lot of time. Or you can look at the lag time. Okay, nobody told you to move. Okay, nobody told you to move either. Okay, this is the lag time, right? The lag time is the difference in travel time, or the lag time is the difference in arrival times between the S wave and the P wave. If it takes the P wave 9 minutes and 20 seconds to get there, and it takes the S wave a total of 17 minutes to get there, how many more minutes after 9 does it take the S wave to get there? Blair, what do you think?
5 minutes and 40 seconds.
5 minutes?
6 minutes.
Okay, so let's look. We have 17 minutes and 00 seconds. That's how long it takes the S wave from the epicenter to the seismic station, right? We said that it's going to take 9 minutes and 20 seconds for the P wave to get there. What's the difference? Well, we take 1 away from 17, right? So we're going to make that 16. And then this is going to be 60, right? So it's going to be 40. And what's 16 minus 9 is? 7. So it's going to be 7 minutes and 40 seconds more after the P wave arrives. So your arrival time should be 12 hours, 7 minutes, and 40 seconds PM. Right, so instead of you could do it that way. You could find the origin time and then work your way forward. There's nothing wrong with that, but it just takes that much longer. Right, Alex? Yeah. Right? It's fine if you want to do that. I personally wouldn't, just because I like shortcuts. It's totally up to you. Questions on this one before we move on to the next one? This is a little bit of everything. Yeah. Okay. Now, I'm kind of just using this, guys, for the examples. All right. Okay, so here we are given. No. Go back. Okay, so here we're given the actual wave itself. This is the actual reading from the seismograph. Okay, where the first spike starts is the beginning of your P wave. And that's going to tell you the arrival time of the P wave. Okay? In this case, this is not lined up with a clock. This is not telling you anything. All it did was, I'm pointing out specifically where the P wave starts versus where the S wave starts. Okay? Remember, the P wave is shorter in size and also more compact. Right? The S wave is further apart and much longer. So the S wave is going to start once it starts having the bigger spikes. Okay? In this case, they are giving you the P wave arrival time is 10:07:40 and the S arrival time is 10:10. Okay? The difference between the two is 2 minutes and 20 seconds. And it is asking you to find the epicenter distance. In other words, how far did they travel? Make sure you have this written down in your notes because this is where you need the scrap piece of paper. Okay? I'm going to introduce to you to the wedgie method. Okay? You're literally wedging that piece of paper in between the S wave and P wave on the graph. So here you have your P arrival time is 10:07:40. Your S arrival time is 10:10:00, and your lag time is 2 minutes and 20 seconds, and you are asked to find the epicenter distance. So how far away is the epicenter? Remember, the lag time is the difference between the S arrival time and the P arrival time. Question? You want to wait like 2 minutes till this is done? Just so you can see it, and then you can go. Okay, so this is what you're going to do. You're going to take your piece of paper. Now that you have your lag time, right, we're going to go back to our graph here. Okay? And you're going to take your piece of paper. Everybody has their reference table out? Right? Take your piece of paper and you are going to mark it. First, you're going to line it up. Okay, come on. You were just there. There we go. Come on. Okay? So you're going to line it up with the x-axis. Take your piece of paper and line it up with the x-axis. Make sure if you're doing this on the iPad, you lock the screen. Because you don't want the graph to move. Remember the triple click? Good. Okay. You're going to want to lock it on the x-axis so you can put your piece of paper there. That's why I said take out your hard copy of your reference table. Okay, now you're going to line up your piece of paper with the x-axis. And you're going to make a line at 0 and label it. Hold your piece of paper. It's easier if you hold your piece of paper vertically. Right? And on your piece of paper, when you line it up here, you are going to, stop touching it. Okay? You're going to mark where there's the 0 line. Okay? Then you're also going to mark 2 minutes and 20 seconds. Watch.
Off the lag time of 2 minutes and 20 seconds. You then take.
So you should have your paper look something like that. You're going to continuously use the 0 mark, so you might want to label that as 0. Did everybody get that far? Guys at home, did you get that far?
Yes.
Okay. All we did was mark the 0 and the lag time, which was 2 minutes and 20 seconds. That's why you have to use the bottom of the piece of paper. Okay? Now, once you do that, you're going to use the wedgie method. Now, the wedgie method is you need to figure out where that lag time fits on this entire curve. So you take your piece of paper and you wedge it in between. So watch what he does.
That piece of paper and you slide it in between your P wave and S wave curve. Once you slide it in between the P wave and S wave curve, what will happen here is where the top mark touches the S wave and the bottom mark touches the P wave, you can determine your epicenter.
Okay, so you have your top mark hitting the P wave, or the S wave, and the bottom mark hitting the P wave. Now watch how he did it. This stayed vertical and perpendicular to the x-axis the whole time. He did not take it and go, oh, we're going to go like this now. Okay, he did not do this. He kept it so that the side where the markings were even and lined up with the vertical lines. Does everyone see how he got 1,400 kilometers? Yeah. Got it? Guys at home, does that make sense?
Yeah, so you have to just move the paper until it hits both lines like perfectly, I guess, right? That's
Right. So the beginning of your 0 should be on the P line, and the beginning of your 220 should be on your S line. Because remember, the lag time is the space in between the two lines, right? If that's the distance, that's going to give me how far the epicenter is away from your seismic station. So what you just found out is that 1,400 kilometers away is the epicenter, is the major problem or the major damage for your earthquake. Does that make sense? Okay, so I want you to take out the worksheet that I posted for you guys. Ella, you can go if you need to. All right, the P and S wave practice. Right? And I want you to do this chart first. All right? So I want you to just take some practice and find, using your reference table, what the P wave travel time will be, what the S wave travel time will be if you have an epicenter distance of 3,000 kilometers, of 5,400 kilometers, of 7,800 kilometers, of 9,000 kilometers. Just a hint, the epicenter distance is the one on the x-axis. So how long will it take the P wave and the S wave to get to you at the seismic station?
right on it?
It's yours. You can absolutely write on it.
Ms. Gonzalez.
Yes.
So for the S wave line going up, right? It doesn't like exactly match up with the 3,000 kind of going up. It's kind of like off. So would it be like, would you take the number and just round it to its base number, or no?
Let's look.
That makes sense.
All right, so I just need the chart. Right, so you're at 3,000. Right, the P wave when you go up is about 5 minutes and 40 seconds.
Yeah.
The S wave when you go up is halfway between the 10 minutes 0 and the 10 minutes 20. So that should be 10 minutes 10, right?
Thank you.
No problem. So you're going to round it to the nearest 10. So 10, 20, 30, 40, 50, 60. When you do this, when you're doing the travel time, you're going to round it to the nearest 10.
Thank you.
You're welcome. I'll check on you guys in like 3 minutes. You should have the top part done in the next 3 minutes. Make sure you know what each line is worth on the x-axis and what each line is worth on the y-axis. We figured out the first one was 5 minutes, 40 seconds, and 10 minutes, 10 seconds. Don't say that, you're not stupid.
I messed it up specifically.
It's okay.
Why? If you're just think you're stupid, always think of me.
Oh, that's not nice.
When you'll be on the highway holding a piece of person with the
Oh, Jesus.
James.
your life. Right? So we're dealing with 30,000 homes. You don't need it yet. And we're just reading those. So we're dealing with 3,000 homes. So 3,000, you go up to the P wave, and you go over. So when you go, and you go over, and you end up right here. And then it's 540 seconds, right? At 3,000, you go up to the S wave, it's exactly on that exact line right here. But halfway between, so that's going to be 10 minutes and 10 seconds. This one here and 10. Right? So you're going to end up rounding it, and you're 10 seconds. Thank you. You're welcome.
All right, did you guys at least get the travel times done for the P and the S wave?
Yeah.
Okay, so let's make sure you did it right. So for 5,400, what was the P wave travel time?
15 minutes and 50 seconds.
For the P wave?
Oh, no, sorry. 8 minutes and 50 seconds.
I got 840 for this. So I got 840. If you didn't get a chance to finish it, okay, I want you to write the answers off to the side. All right, because I want you to do it yourself. 840, right? And for the S wave, you should have gotten 1550. Yes? Okay, for 7,800 kilometers, what'd you get?
11:20.
But Miss Gonzalez,
What's that?
I'm confused because it's like right in the middle of the line.
Right, so that's
Like
going to
a
be
huge-
10. So this is 5,400, right? And we're looking at the S wave. So if it's 54, it's 52, 54. Then you go all the way up. And for the P wave, right, it's about 840. And then when you go all the way up, it's halfway between the 40 and the 60. So you're going to get the 50.
Okay.
Yeah. Okay. How do I go back? Go back. Right. Okay. For 7,800 kilometers, what'd you get?
11:20.
I got 1110. Well, let's see. Right. For 50, we said 7,800, so 72, 4, 6, 8. For the P wave, it's in between the 00 and the 20, so it's going to be 1110. Okay, for the P wave, and then for the S wave, all right, it's directly on
16 minutes.
2020. Okay, all right, so I want to skip forward a little bit just so that you guys can try this for homework. And remember, it's homework, so you're going to try. That doesn't mean I'm grading it. Okay, even though we have like a minute or two. Right? When you were doing this, right? Now you are given the actual data, right? The P wave is where you have the first jump. So the first jump, I mean, my marker is a lot thicker than it actually is, okay, is going to be, the arrival time is going to be 104.
It's not a 1:04 time.
No, it's 104. Okay? For the S wave, remember, mine is a lot thicker than it actually is. When you do it, it ends up being 106.20. Okay? The lag time is the S wave time minus the P wave time. Oh man, stop it. The P wave time. Okay? For the epicenter distance, you are going to use the Wedgie method. Okay? Once you have the epicenter distance, you can answer the rest of these. Okay? Because then you can say, how long did it take the P wave to get there? How long did it take the S wave to get there? And you can figure out what the origin time is for each of them. Okay? This is your homework for tonight. I want you to do the rest of this worksheet. Do the best that you can. We will go over it tomorrow before death, destruction, and despair. No problem. When we do tsunamis, volcanoes, and so on and so forth. Okay? Be good. Stay safe.
Have a good day.
Bye. Be good.